welcome to the recording of the lecture for Chapter 3. This week we get into dynamic routing. Last week was static, where you manually signed everything. This week it's dynamic, where the router tries to figure out, based on the algorithms that it's loaded and you turn on, actually work and find all the routes necessary. So we're going to explain the purposes of dynamic routing, how they're used, compared to dynamic and static routing. We start out with a routing protocol called RIP version 2. We'll kind of talk a little bit about the different versions. And then Chapter 3 we'll talk about the routing table. What information is stored. Now, one thing I'm not going to cover is the IPv6 packets and information, but we will talk about IPv4 that's used to it. So let's get into dynamic routing protocols. Now, they've been around since the 80s, and both IPv4 and IPv6 have versions of these routing protocols. Now, there's two major classifications. There's an interior gateway protocol and an exterior gateway protocol. Interior pretty much says, hey, this is the stuff within my company's purview, what things I'm trying to control in my network, where exterior gateway is where I'm going to say, I'm going to start talking about going to other networks on the internet. So we usually don't, because usually those are ISP type protocols. So most of the stuff that we're going to cover in this class are all interior gateway protocols. Within the interior gateway protocols, there are two areas. There's a distance vector and a link state protocol. Now, distance vector says, how far am I going to go? As far as, is this a good route or not? A link state just to say, what are the states of all the links that are connected to me? What status are they in to decide what's up? Now, EIGRP, they've got it as a distance vector. It's a proprietary, used to be proprietary Cisco protocol, but 3 or 4 years ago they opened it up so anybody can use it, because I think we probably having troubles with everybody was going to OSPF since it was an open source protocol and worked quite well. Now, we also see that IPv4 and IPv6 have versions of this. Now, you see that ISIS protocol. We will not do anything with ISIS in this class, but it is a valid link state protocol. Now, different components to this, basically what routing protocol, I'm just trying to exchange information between routers to try to understand what kind of routing information is at my disposal. So some of the major purposes is I want to discover remote networks. I want to make sure my information is up to date. I want to make sure the router says I still got to choose the best path to route a packet through, and then I got to have the ability that find a new best path if there's a problem with the network that forces us to change. Now, how does it do it? Well, it does it by three major things. One is the data structure. What kind of data is in databases is it storing? And all this information is kept in RAM. Routing protocol messages. What messages are being sent between routers to discover information? Whether it's exchanging routing information, whether it's learning to maintain that. I'm just trying to maintain as much accurate information about the network as I can. And then, of course, based on the messages and data structures, the algorithm that says how am I processing that information to determine the best path. Now, just a little bit of reminder, last chapter was static routing. We said it was primarily used, makes it ease of maintenance in the routing table, smaller networks that aren't expected to grow very big, 4 or 5 devices that you're connecting to, not a bad deal. You can make those manually changes. Maybe it's information routing to or from a stub network. And as you remember last week, that a stub network is, hey, it's a network that only information coming in, but there's no additional networks going out of this network. And then I want to specify a static route. So those are valid points for using static routes. Now, some advantages and disadvantages of static routing, or at least one, they're easy to implement. Disadvantage, simple topology is not bad. Advantages on the static, it's very secure. But disadvantage, it's hard to configure as the system goes better. Route to destination's always the same, but I have to manually intervene if I want to make changes. And then there's no routing algorithm update mechanism, so there's no extra resources on the CPU and RAM. Now, for dynamic routes, it's suitable for all topology, no matter what kind of multiple routers are required. It's independent of the network size in most cases. It automatically makes changes as the network changes, as things go up, down, added, all of that changes. Disadvantage, maybe a little bit more complicated to implement. It's less secure because now you got additional settings I got to make. If you want to make it secure, because I'm passing information on, if I want to really protect it, I've got to protect it myself. The route depends on the current topology. So if the topology changes, you want the dynamic routing protocol to change. And of course it requires more CPU, RAM, link bandwidth to do all that. Now how do I set up, we're going to use a routing protocol 2. Well, it's relatively simple to start. Get in configuration mode, you type router RIP, and then specify the network. So if I'm looking at router 1, I specify the networks that are not connected. I want to specify these are the networks I want. So router 2 says I need to specify the 2 network, and I need to specify, it says I know about this network. So router 2 says these are the ones I know about. Those are the only ones I know about at this stage. So who's connected to me? That's it. Oops, sorry about that. So I'm looking at which 2 networks are connected to me. And you notice even though this is, router 30, it's on the classful boundary. Now, what do I see? If I do a show IP routing protocol, one you're told here, it's RIP is the protocol. You're also told there's a couple of versions of RIP. So you got default version control. This one is version 1. So if I set it up running router RIP, that is version 1, and it tells me I'm sending version 1, and I can send version 1 and receive version 2. And then it tells me which networks am I routing for, and it tells me more information. So it tells me the administrative distance and what the gateway is and how long it's been up. It'll also show the show IP route. All of these begin with the letter R. And as you can see, they're routing class, they're classful boundary, classful 24 in this case. And you see administrative distance. So, now, how do I set version 2? Well, it's router IP, puts you into router configuration mode. You specify version 2. That's all you got to do is specify that it's version 2. And now if you do the show IP protocols, now you see I'm sending in version 2 and I'm receiving in version 2. I no longer am sending or trying to compensate for version 1 anymore once I specify version 2. Now, because they summarize on major network boundaries, what happens if I don't want to force you to be on classful boundaries? So if you're class C, that means what? I take the first 3 octets. What happens if I don't want that? Well, to turn off that automatic summarization. Version 2 allows you to turn off that auto summary to allow you to be more specific. So you specify that using the no auto summary command. This command has no effect in version 1, so it only applies. So, and then if you show IP protocols, it'll tell you that auto summarization is not in effect. As you can see here, this message here says automatic network summarization is not in effect. Now, if I'm setting out passive interfaces, that means ones that don't change a lot, I'm wasting interface resources, I'm wasting bandwidth, and potentially it's a security risk. Now, if I want to send out the default route, I need to make sure that I specify it. I have to tell it router IP and do default information originate. That command then says when I'm advertising my network, I'm going to specify what the default route is on router 1. So if I have specified one, in this case I've done a default route 000, I'll send, the interface S001 and that IP address to the next hop. I want to make sure that's propagated as I let router 2 know and beyond. Now let's take a look at the detail of the routing table. So you got a network out there, and you do the show IP route. That's why you can see the routing table. Now if you look at each of these entries, if you're a directly connected site, our IP understands that, and those directly connected are identified by a C and an L. The link state and the directly connected. And it'll tell you directly connected, and it'll tell you the interface that it's connected to. Now remember, directly connected has the highest administrative distance of 1. So it's going to try to go to the directly connected interface altogether. Oops. Now for remote networks, you're going to get the source of the route. This is on each line entry. You're going to get an administrative distance. You're going to grab RIP has letter 1, letter R, the destination network, the administrative distance, and by default, RIP is 120. The metric is how many hops is it to get to that next hop network, because RIP uses the number of hops as its metric. The next hop's address, the route timestamp, how long has it been on, and what its interface is. Now, showing that there's several different layers in this. So the ultimate route is the routing table. That's the one that's either the next hop or next exit interface, and that's the one that everybody's going to try to go to first, because it's got the highest administrative distance, or the lowest administrative distance, the most trusted. Level 1 says, hey, I'm going to go from my network out to the next hop, so I'm looking for just a little bit less information. Now the parent route, level 1 parent routes, I'm going to go to that route next, and then I'll go to the child route. So if I'm looking at a process of how to route a packet, first is I'm going to say if the best match is the level 1 ultimate route that is connected, I'm going to forward that one. If it's a parent route, then I'm going to go down to look at the children route, the level 2 route, and I'm seeing for which is the best match. If there's a match with a child 2 route, that subnet is used to forward the packet. If there's no match, then I have to still continue on. If the router continues searching the level 1 subnet level, I'm looking for that default route if there is one. If now there is no match at all, the level 1 supernet route, try to any way possible to route anything out, and if there's nothing in the routing tag, no match for any route, then the router just drops the packet. So hopefully that gives you a little bit more information. Look at the longest match. It's looking for that longest match, and that's what you're going to see.